Hi, everybody. My name's Tom Peterson. So I work at QA Cafe and I work on CloudShark there. And over this past year, I set up a honeypot. So we're going to take a look at analyzing some of this honeypot traffic. Trying to come up with a catchy little tagline at the end there. I had chumming the shark-infested waters. So the shark-infested waters would be the internet. And we set a bucket of chum out there to see what would happen. So just to go over what we're going to talk about today, we're going to start and just define what a honeypot is. We're going to look at some different types of honeypots because there are a few different kinds. And then I had an example that I've been running, which really just sits there out on the public internet, and it accepts and listens to any TCP connection that it receives. And we'll take a look at some of those captures. I'll be showing them live using tools, obviously Wireshark. But we'll also take a look at some other tools such as Suricata, which is an IDS program. So essentially you can run a PCAP through that IDS and it will print out alerts based on signatures. And we'll actually take a look at some of these captures using Zeek too, which if you saw the keynote today, which it just has been described pretty well. But I'll go over each of those tools. And unfortunately, I'm not going to be able to share these captures. Normally I would try to send these out so that everybody can follow along. But as we'll see later in the presentation, they've got some pretty sensitive information in them. So unfortunately, I won't be able to share them, but we will take a look, and I'll share my screen, and we'll go over those. So just a little bit of background on who I am. Tom. I really do love packets. I love looking at packet captures, just networking in general. I live up here in New Hampshire. It's a little rainy here now. And I got my start in networking at the interoperability lab at UNH. Well, that was back in 2005. What the interoperability lab is there is it's a group, and what we do, what they did there is all different vendors from all different companies can send in their networking equipment. And what the interoperability lab does is plug those in together, test them to make sure, devices from multiple vendors can all still interoperate and work together. And right now I work at QA Cafe. I work on the CloudShark product there. Last year was my first CloudShark presentation, and I had a really great time. It's so fun to be here with all of you. I'm really excited to be here again this year. And if anyone does have any questions, that is my email address there too, if anyone wants to follow up offline or get in touch with me. You can use that email. So to start, I'll just start to talk about, why did I even do this? Why did I set this up? Like I said in the last slide, I really do like packets. I like looking at them. And I was really just kind of curious to see what would happen out there on the internet, setting up one of these honeypots. Just out there listening to everything, what's going to happen? So I was just kind of curious about that. It also did give me a lot of practice using packet analysis tools. Things like, the Wireshark profiles. Zeek is something fairly new to me for the past year, so I didn't really have too much experience using it, and I wanted some. So this was a good way to get some use with that tool, see what it can do. I was also curious what Suricata and those alerts, what alerts will flag from that. And I also needed a topic to present at SharkFest this year. So that was another reason, just so I could be here with all of you. So some history about what a honeypot is. There's this great book called The Cuckoo's Egg that was written by Clifford Stoll back in 1989. This was kind of the first example of a network honeypot. So Clifford was working at Berkeley, and he was in charge of billing all the various departments for their computer use. And he found it was a minuscule amount, but he couldn't allocate for, I think it was somewhere around $1, less than $1, maybe even. And as he went through and investigated this, he found that there was an attacker connecting to that computer and using it when they weren't supposed to. So what he did, and these are kind of some of the features or functions of a honeypot, is he would get an alert every time the attacker connected. He'd monitor everything that was typed. Actually had those printed out so that he could review them. And then another thing he did is he actually made some fake documents and put them on the server, having names, relating to government contracting projects, to try to get that hacker to download those documents, which he was successful at that too. He did also keynote at SharkFest in 2012. So to define a honeypot, there are a few things it should do or not do or be. So a honeypot is something that lives on the network. It should look like a valid network resource. And there should also be no valid users accessing it. So that way, if someone does attempt to access it or interact with it in any way, you'll know that that's not one of your users. That could be a bad actor. So naturally for that, you do have to monitor the honeypot. For me, I want PCAPs of everything. That's how I do my analysis. And some other things you can do is, if you do see someone accessing that honeypot, you could have an alert, something in your IDS to create an alert. Maybe have it send you an email if anyone goes to connect to it. But those are some of the bare requirements, minimum requirements for a honeypot. So these are some of the things that they can do. As we mentioned in the last one, they can detect attackers. So if anyone is interacting with it, you'll know that there's some sort of attack going on. If that's inside your firewall, you know that your network has actually been breached. But you can use, the honeypot to then track and try to entice the hacker and look for, any sort of lateral movement, see where they're going to try to go next. There are also types designed to waste their resources. So one resource is time. Any time that the attacker has spent interacting or trying to gain access to your honeypot is a waste, because it's not a real server. It's not something hosting anything sensitive. So you're wasting their time there. There are some other techniques too to waste their computing resources. So something like, exhausting their CPU or RAM or network resources. They can be used for that as well. They could also be used for threat hunting, and that's kind of what we're going to talk about today. So this is one, set up outside your firewall, and you're looking at it, analyzing it to see what sort of threats you might be susceptible to. And the last one for me is, like I said, curiosity and fun. They're a lot of fun. Going to that fun one, this is an XKCD cartoon that I liked a lot. Kind of just showing someone who maybe set up a bunch of virtual Windows machines, networked them together, and they all get infected with a virus. And you're kind of collecting those viruses and looking at them. It's maybe a little bit of a odd hobby, but it has been really fun. So now that we know what a honeypot is, we can go into some, actual classifications on them. So, to break them down right off the bat, you could break them down into production honeypots and research honeypots. Production honeypot would be something, living inside your network, inside your production network that you're monitoring for attackers. Research honeypot, more like what we're going to be talking about today, just to gain knowledge, see what sort of attacks are happening, how often, what types, and gaining some knowledge of what's going on there. Another way they're classified is by their level of interactivity. So this is what the honeypot actually does. A very low interactivity honeypot would just listen on a port and alert on a connection. Moving up, there are high level interactivity honeypots. So this would sit out on the network and maybe look like an FTP server or a telnet server or an SSH server, and an attacker connecting to it might get presented with a login, and you accept any password, so you can see what passwords attackers are trying to use. Once they are on the system, you can take a look and see what they're going to try to do on that machine if it were a real valid network resource. And then you do have pure honeypots as well. So this would be a real device, maybe something like a Windows server hosting remote desktop, and it's a real legit device. Those would make me a little nervous to run. I'm not advocating for any of these in particular. There are also honey networks. So that would be a whole collection of these honeypots emulating an entire network. So that might have something like a Windows domain controller on it, various other servers. And you could watch the attacker, moving between them. And there are a few different types of these honeypots. One type is a detection honeypot. So this, I think it's a really interesting idea. My home router, it turns out, actually has one. My home router sets up another interface on the LAN, and it listens on just all common ports, everything, SSH, FTP, and if anyone connects to that IP address on that port, my home router generates an alert, and I can go in and shut that down. So if I did have some IoT device that got infected, I could see it trying to move around to other devices and try to find other things on the network. Chris Sanders actually has just written a new book all about these detection honeypots. It just came out, I think, maybe within the past month. And after reading it, I'm very interested in these more. I would definitely recommend his book if you're interested in learning more about these types of honeypots. Another type is, they call it a tar pit. So this is one of those honeypots designed to exhaust an attacker's resources. The first instance of this is called La Brea, which is named after the tar pits in LA that used to, an animal would get stuck in them, and it was a big tar pit. So these are used to exhaust an attacker's resources. One example is you might have your server responding to any SYNs that come in, but then it sends a fake SYN ACK and doesn't actually hold any information about the connection. So you're not actually using any RAM or any resources, but the other side is going to keep that session and maybe keep setting an ACK over and over again. Another really interesting one that I have set up once is endless SSH. So in the SSH protocol, if a client goes to connect to a server, the first thing that each side does is they send information about what SSH software they're running. What endless SSH is intended to do is, once you get the client's initial packet with their information, you start sending that server response about what this server is supposed to be, but you do it packet by packet at a time, character by character, and you just drag that out as long as possible. So the other side's just continually waiting to get that response from your server. HTTP has ones that are similar. Everything I've read and the research I've done on these, there's so many bots out there. There are so many resources that attackers have under their control. I'm not sure how useful this would be to run. But again, they're kind of fun to look at and play with. Sorry about that. All right, so the honeypot that I set up, again, I was curious about what happens on the internet. What happens if we set something up and just monitor it and watch and see who tries to connect to it and what they try to do. So I set this up on DigitalOcean. So there's a little VM running out there. They call it a droplet, but it is just a CentOS 7 Linux machine. And what I've configured it to do is accept any TCP connection on any port. And it's going to accept that connection, finish the three-way handshake, and then it's just going to listen. We'll see what the other side, the attacker, sends after connecting. But my honeypot is not going to send any other data. After about a second or so, it will reset the connection. We're just capturing the packets just to look at them. So, as far as level of interactivity, this is about as low as you can get. So a little just technical information on how it works. And I do have a GitHub repository on here with some of these examples, if anyone wants to take a look at some more of the commands used to set this up, some of the actual details. But it is, like I said, DigitalOcean. It's running CentOS 7. And it has, one interface on the public internet. So that has a real IP address. And then internally, I've added a NATed interface. So this is an internal interface. And the way this works and how it's set up is anytime someone connects, say, for example, someone's trying to connect on port 80 on that NAT interface or on that public interface. The way I have things set up, it's going to take that packet and forward it to the NAT interface on just one port. It's just listening on a single port there. And using the program Netcat on Linux, which is just an easy one to use to send and receive network data. It's just sitting there listening on that NAT interface. And then I have also set up a ring buffer packet capture setup using TCP dump. So what that's going to do is, say, for example, it captures and it captures, so I want the PCAP size to be maybe 10 megabytes. And I have 10 of those. So what the ring buffer does is it starts the first packet capture. And then once it hits 10 megabytes, it'll switch to another file and start capturing into a new PCAP. And once it goes through all those 10, it goes back up to the start and rewrites over the first one. So, the intention and the reason why I'm using that is just so I don't fill up the disk immediately. After running this, it will kind of just stay within that allocated space there. And I did come up with a quick little diagram to try and help explain this and show this. And again, there's a link there to the GitHub repository where I have some of these example scripts and commands on how I set this up. But there's a honeypot droplet out there. The public IP interface is connected to the internet. And then internally, I'm using that to forward all 65,000 TCP ports to an internal NAT interface on a single port. And that's where Netcat is listening. So it's just sitting there listening for any traffic coming in. And then after about, I think it's a second or so of not receiving any traffic, the firewall sends a reset and closes that connection that was coming in from the internet. All right, so now we're going to start looking at what happened after setting this up. So we'll take a look at some of the general statistics of what we found after running this for a little while. I did find a few things that were particularly interesting, so we'll go over those. A couple surprising things I wasn't expecting. And then we'll actually do a live demo, and we'll take a look at analyzing some of this PCAP data using those tools mentioned earlier, so Suricata, Zeek, and Wireshark. These are all open source tools. I will be using CloudShark to show them, but I'll make it clear, you know, as we're looking at things in CloudShark, where this data is coming from. It'll be pretty clear where all the Wireshark data is coming from, and I'll show you, you know, Suricata and Zeek as well. But these are all open source tools that you can run yourself. CloudShark's just kind of a web interface to those. And it's the tool I'm just the most comfortable with, really, to be honest. So taking a look at just some generic statistics. I tried to capture these in like 1 day chunks to take a look at them. This is what I found on, it was September 29th, where these stats are coming from. So in a single day, that honeypot generated 456,000 or so packets. I had 4,678 different endpoints trying to connect to it, all in 1 day. 621 of them were from China. You can find out with, you know, the GeoIP information provided by Wireshark. Taking a look at Suricata and what that IDS alerted on during that day, there were 120 high severity alerts, and we'll dive deeper into some of those. It classifies, you know, what it's seeing in these alerts and these signatures into different categories. So there's 120 high severity alerts. What I found the most of was remote desktop. So in that single day, almost 9,000 remote desktop attempts. So that's clearly, you know, what attackers are trying to exploit the most when they're just doing kind of a blind scan. Again, this is a Linux system, so it's not even running remote desktop. But we'll see a lot of these bots and things out there aren't too smart. They're just trying to cast kind of a wide net. And I did also find 1,500 SSH attempts, someone trying to SSH into this honeypot. Those are some of the high-level statistics. Right. So I do want to just go over these tools real quick, so we can explain kind of what they do and how I use them, and some of the kind of maybe not pros and cons, but what each tool is good at. So, you know, each tool does have kind of things that it's trying to attempt to do. And again, we'll just look at that in CloudShark, but it's these 3 open source tools. So here's the one we're all familiar with. At least I hope everyone here at SharkFest is familiar with Wireshark at least a little bit by now. So with Wireshark, you know, we're going to be looking directly at packets, you know, all the way from the Ethernet layer through IP, TCP. You're looking at all that data. So it's all the data, every bit and byte that happened on the network. And that's a great pro. You know, we do have all the data, so we can get everything we need. But at the same time, it's all the data. There's a lot of it. There's a lot to look at there. You know, some great features in Wireshark. Profiles. So these are ways you can kind of configure Wireshark to have, you know, your preset filters. So you don't have to remember those filter expressions every time. You know, depending on how you want the column set up, you can set that up in your profile as well. There are, you know, a set of analysis tools that Wireshark comes with, things like the network endpoints tool or conversations. And we'll go into a few of those too, as we're looking at this example PCAP. So Suricata, for those who aren't familiar with it, is an intrusion detection system. So this, you know, reads the PCAP, and Suricata is based on signatures. So there are a ton of signatures out there. We're using the Emerging Threats Pro rule set. And what these signatures are doing is they're looking for information in the packets. So there might be a signature where, say, the rule is looking at HTTP traffic, and if it ever sees the text wget or curl, it's gonna generate some sort of an alert. Typically, they're looking for things like malicious network traffic that would indicate a machine was infected or attacked. It can use signatures to look at things like this looks like an infected machine trying to communicate back to a command and control server under an attacker's control for commands. Well, it's really powerful, it's really interesting, but since it is signature based, not downside, but one of the things that comes along with that is it does need to be something previously seen. It needs to be something someone wrote a signature for. So if you are looking at, an infected machine, if it's using, or if it's infected with known malware, something, the community knows about and people have written rules for, you can detect that. But if there's no signature, if there's no rule for the traffic you're seeing, it's not going to generate an alert. So we'll take a look at, some more of these alerts as we go through the traffic. Well, what else is nice about Suricata is when it generates an alert, you do get that, IP address, the TCP ports that it's using. And from there, you can create a filter to the PCAP to look at just those packets. So then you can use a tool like Wireshark to kind of dive more in depth. Excuse me. And then the other tool we'll be looking at is Zeek. So like I mentioned, this is kind of a new one for me. It is behavior-based, so it's not generating any sort of data based on signatures. What Zeek does is it generates log files. So is this going to show us, as it reads a PCAP, things like all of the HTTP user agents it saw in that PCAP, and generate these log files where you can kind of go in and get a really high level and quick look at what's going on in that PCAP. That was mentioned in the keynote this morning, there are also tons of custom Zeek scripts. The one I'm going to be showing you and using today is a pretty stock, basically what you would get from Zeek without writing custom scripts or configuring it too much. There are also plugins for Zeek. There's a whole package manager infrastructure for Zeek, so you can add plugins, looking for maybe particular malware or different types of traffic. And so since that is displaying info from the PCAP data, all those log files, using that example with HTTP user agent, you can see all the HTTP user agents that were noticed in the PCAP. And then again, we can also create a filter based on that data to get back to the PCAP data. So we could look at the log file entry for a particular user agent and pull out the IP address information, the ports, and create a filter from there that we could use with Wireshark. And then CloudShark, this is the product I work on here at QA Cafe. This is a kind of a web interface to these packet analysis tools. But these are the tools that we are using under the hood. So I'll just make it clear, as we're looking at the data, where it's coming from, what tool, how you could do this on your own as well. Just keeping an eye on the time here too. So without further ado, we will take a look at a PCAP from this honeypot. So this is CloudShark here. We do have the PCAP file open. So this is from the honeypot on September 29th, 2020. So this is kind of that Wireshark data, all the PCAP and packet information. This is all coming from Wireshark. So you can look at all the TCP fields that you're used to. It's doing all the same. It's using Wireshark to do all this dissection. Hold on. And from here, you can, some of the easy information to get, size of the PCAP, the number of packets from that PCAP NG. This is where we got some of those statistics. The cap infos tool that is provided with Wireshark can give you all of this information as well. So when the capture first started, when it ended, how long it was, number of packets, all this kind of, you know, high level meta information, average packet size, things like that. So one thing we'll see is this is from one day of running this honeypot, and it's 500, you know, between 400,000 and 500,000 packets. You know, we actually limit the view here in CloudShark to 400,000. That's the most we're going to let you kind of scroll through and look at like this, because really that's just so much data to go through. And it really does, here, I've got a little note here I can throw up there. So it's a huge capture file, not necessarily either in size. 44 megabytes isn't, you know, the largest PCAP file size that I've dealt with, or anything like that. But the number of packets makes it difficult for a tool like Wireshark to chew through and deal with. You know, it's a lot of really small packets, and it's a lot of different connections. So as Wireshark is going through and analyzing this PCAP, it's taking a lot of resources to store, you know, information about every single connection. So one thing that I have done is I have split this capture up. So edit cap, this is another tool that comes with Wireshark. I've taken this 1 day's worth of PCAP data, and as we do some more analysis, as we go into some more of the Wireshark PCAP analysis, we'll be looking at smaller chunks. So edit cap here, you can give this flag to specify, you know, a particular number of seconds, and you give it one PCAP and a file name, and it's going to take this PCAP for us and split it up into, I think that worked out to 6 smaller PCAPs with 144,000 seconds in duration in each one. But moving on to take a look at some of what we can analyze from this large PCAP here. Some of these analysis tools. So these are the analysis tools in CloudShark that should be somewhat familiar. We can take a look at something like network endpoints. So this is in Wireshark as well. And what this is going to do is just go through every packet, all the PCAP data, and figure out all the different endpoints that are in this capture. And you can see it is taking quite a while because it's going through and tracking all of that. So you can see here there's 4,678 endpoints. And we've got some information, you know, the IP address, the packet sent and received from that endpoint. There is GeoIP information that you can enable in Wireshark as well. So you can take a look at, you know, where these connections are coming from. If we sort here just based on packets, everything is a little slow because there's a lot of table data. Here you can see this is the DigitalOcean droplet that I'm running. So this is the Honeypot's IP address here. So that's running in DigitalOcean. And now you can take a look at some of the endpoints that sent the most data to and from it. So you can take a look at that in packets or bytes. You know, this GeoIP information, you can also build a map view. So here, this one's kind of interesting too. Just to take a look at all that GeoIP information. You know, where are these connections coming from? If you set up a honeypot like this on the internet, what can you expect to see for GeoIP information, for where people are coming from? So here, you know, we've got the map and you can kind of hover and highlight and look at them. But if we just sort again by endpoints, here we can see all the countries tracked in this PCAP. So again, here you can see this is where I got that information. China, I'm getting the most connection attempts from China. Just going through, they're everywhere. They're coming from a lot of different places. So I found that to be an interesting thing to look at. And China did typically come up as the most. And all the ones I've looked at, you do see, Russia as another one, Brazil. So some other information we can find through here. You can also take a look at the protocol hierarchy. So Wireshark has this in it as well. And what this is looking at is just what protocols are people using in the PCAP. So we can see Samba. Let's sort this again by frames. So, naturally, everything's a frame. So that one shows up the most. Ethernet. I'm just running this on IPv4. And then TCP, and now you can kind of look at a breakdown of what protocols people are using to try to connect to this honeypot. So there we've got SSH and the number of frames detected there from Wireshark, SNMP. You can go through this whole list. And again, these are kind of just some of these high-level overview statistics. I'm not going to dive too far into any of these with this large PCAP, but we can take a look at the threat assessment as well. So what this is running Suricata on the PCAP using the ET, emerging threats rule set that they provide. So if you're setting up Suricata, you do have to, in addition to just setting up Suricata, you have to give it a set of signatures to use as it's going through the PCAP and looking at the traffic to generate these alerts. So again, here you can see 109 high severity alerts. There's a lot of medium ones, some low. And once we kind of get into a smaller PCAP, we can go in and look at some of these in a little more in depth. And then another really interesting one is that final tool that we talked about, Zeek. So here we can see a list of the log files that Zeek generates by default. First thing, and one of the biggest logs is always the connection log. So this is just a log of all the connections. You can see the number right here. Suricata is also gonna, trying to keep all these tools straight. Zeek can also look through all the traffic and create a DNS log. So using that, you could look at all DNS queries seen during the PCAP. Files is a really interesting one. So you can look at all the files that were transferred over the course of this PCAP. If you get something like, it'll have the SHA-1 hash in it and everything. So if you want to, pipe that over into a tool like VirusTotal, see if that file is known malware, you could use the files log to very quickly get in there. HTTP, that was the example I gave earlier. We could look at a list of all the user agents. We can go right into HTTP actually. Take a look at this. So this is an example of one of these log files that Zeek is generating. So if you look at this on the command line, it is just a text file, tab separated. Here are the columns at the top. So you've got a timestamp, and each row is going to have a unique ID. We've got the IP address information, and now you can just see all the HTTP information is pulling out from an HTTP connection. We've got some views here. Here's just a list of all the user agents. You see a lot of HTTP requests didn't have one. 473, so this is just a count of all these different unique user agents. This is an interesting one, Net System Research Studies. They're nice enough to at least put that in their user agent, so you can actually go and look at their website and see that's not really malicious traffic. There's another interesting user agent, Hello World. So we saw that once. on the 29th in this PCAP. So again, I did mention the files log. So here you can see some information about just all the different file transfers. If we take a look at SSH, you can take a look at all the SSH connections that were attempted to this honeypot on the 29th. If we want to look at, maybe say just the client name, we could take a look at just a list of all the different client values. So you see PuTTY, OpenSSH. These are some weird ones. We'll go into that a little more in depth as well later. Yeah, every day is a little different with these PCAPs. There's some SSL traffic as well. One interesting log is this weird log. So this is another log file that Zeek generates. And it does generate this by default. We didn't really configure anything special for these to show up. But it's just logging weird things it saw protocol-wise. So you see something like a bad HTTP request. I ended up seeing a lot of these while running this honeypot. If you just look at all the different weird things Zeek noticed, lots of bad HTTP requests. A lot of the software out there that hackers are using to try to gain access to a server or to do malicious things aren't really written too well. It turns out, the lines aren't terminated correctly with the right carriage return new line. So there's some interesting finds as well. Let me close out this Zeek view. Sorry, the Zoom interface is getting in my way a little bit here. All right, let's get back to, there we go. So this is that first PCAP on the 29th. We go back and take a look at a list of some of these honeypot PCAPs. We've got this set up so you can view it, when the capture started, when it ended. So this was the full day here. You can see that's from September 29th at 12 to 12. And then again, using edit cap there, we have sliced it into smaller, much smaller, more manageable PCAPs. So we can actually kind of take more of a deeper look into the traffic that was sent. So let me go back. See, this was the full day here. And I've got a link to a smaller one. So now we are looking at, a lot less packets, a lot less endpoints. If we want to take a look again at the network endpoints tool from Wireshark. Now we've only got 1,000 endpoints. This is just going to be a lot easier to kind of navigate and analyze and filter. So if we do see one of these interesting endpoints, if we sort by packets there, we can see, let's say maybe this one here from Germany, megaservers.de. And since we have that IP address, you can get that filter expression in Wireshark. So now we can just look at the traffic sent by that IP address and create your filters from there. I know Betty is a huge fan of profiles. I am too. So you can actually also use these profiles. If I open this up in the editor, we can change some of these columns around. So something like the time from the start of the PCAP might not be super interesting. We're trying to look at this and correlate data, but using something like UTC date and time is going to be a lot more helpful there. Things like the source and destination TCP ports. We can add all those as flags. For filters, typically when I'm looking at these and using a profile, one of the earliest filters is just looking through all the packets for any frame that contains the text wget or frame contains. If we add that to our profile as well, once we've saved this, you might generate your own kind of profile for this sort of analysis. So now we do have those columns set up correctly, the actual date and time, especially when you've split this up into 6 PCAPs, it can be hard to remember what slice of time you're looking at. So UTC is useful there. And then some of that filter we just created, wget or curl. If we apply this, these were always pretty interesting packets to look at. So if we take a look at this HTTP one, and then using Wireshark's follow stream tool, we can take a look at the HTTP stream that this person sent us. So here you can see this is an HTTP GET request. So it's trying to connect to the server and get a web page. And this is the page it's getting, /shell cd into the temp directory. Whatever this one's doing, it looks like it tries to remove everything. And then it goes and downloads a file from some server, probably under the attacker's control, and it executes it. This was actually that user agent we saw earlier, hello world. I have gone out and tried to download a few of these files after seeing them in the Honeypot captures. Usually there's some sort of Linux shell script. I think typically from the Mirai botnet, those things are still out there. They're still trying to blindly connect, which I thought was interesting. So there's a few of those in here. And if you did want, you could try to download that file that the attacker's trying to get you to download on a real server and investigate it, look at it a little further. One thing I found while looking at a lot of these Honeypot captures is whoever's sending this HTTP GET request, that file that it's trying to wget actually doesn't exist anymore. A lot of these just seem to be old servers that are probably just still up and running, just blindly trying to do this, but they're not really maintained anymore. Just extra stuff out there on the network. Right. So that's Wireshark and a little bit about profiles. If we go in again and take a look at the data Suricata is generating, here we can take a look at threat assessment again. And now let's actually take a look at some of these high severity alerts. So we can take a look and see what Suricata is alerting on, what it's finding in these PCAPs. So here, these are just the alerts that Suricata is generating. We've got some IP address information here. Generic name for the alert. If we take a look at, we'll take a look at this one. Incoming basic auth. This is the information you would see from Suricata. In this case, it's just a name really of what it detected. It does have information about the time, what protocol it found this traffic in. Here we can look at the source and destination IP. So again, you can get a filter back to the PCAP from here. I'll pop open one of these real quick so you can take a look at what one of these signatures looks like. So this is an alert on HTTP traffic. And it looks like what this is doing is it is looking in the HTTP header and it's looking for this string with this content. And if it finds that, it's just going to generate this alert. But again, going back, if we want to find out more about what Suricata is alerting on here, using that IP address and source and dest TCP pair, we could look at something like follow stream within Wireshark. And then we could also go and show only this stream which is going to give us that filter expression back to the packets from Suricata. So kind of having all these tools and all that PCAP data with it is really nice. I think during the keynote, I'll getting ahead of myself, sorry. But yeah, now here you can just see all the packets sent back and forth between that person and the honeypot. And going back to those alerts, this was mentioned earlier today during the keynote, but there's that community ID within Suricata as well now. So that's actually taking a hash of this information, the IP import information. It's generating this hash. And it sounds like this was just added into Wireshark. So now you would actually be able to make a filter just based on that, that community ID hash. But the Zeek tool also does support that as well. So if you want to look through the Zeek logs for anything matching the same connection, you can actually go in and look at that Zeek log. And here we're just looking at that community ID. So you can see that way over there. And I really can't wait for Wireshark to support this now, just to be able to build a filter based on that community ID that all three of these tools will support. So you can get back and forth between all of this data easily. There is a lot of synergy and reasons why you'd want to use different tools here. So this first one, I did kind of set this one up ahead of time. But this was something I thought was really interesting as I was looking at these. This threat here is a botnet check-in. It's actually one of the reasons why I don't feel comfortable sharing these PCAPs with everybody. Because what this is, when I looked into this, you can take a look at that signature there. But doing some Google and some research, this is an infected machine checking in with my honeypot. If we look at the payload Suricata is alerting on here, we've got some information about the infected machine. You can kind of make it out. It's a Windows desktop PC. It's got some information about how much RAM it has. If we take a look at follow stream there, this is that information again. And what I found is running this honeypot, that honeypot might have been an old command and control server for some malware and infected machines. This one wasn't too bad, this check-in from some infected machine out in Hong Kong, it looks like. But I've found machines sending me their passwords, their admin password. I found other infected machines, and through these Suricata alerts, found them, the machine was infected with Bitcoin mining software, and that machine is trying to connect to my honeypot to give me Bitcoin information from some infected machine. I thought that was really interesting, and that wasn't necessarily something I was expecting. But since we are living in this cloud world these days, that IP address was used by somebody else. And it looks like in this case, my IP address was used by somebody not so good. One of the things just thinking about these is, could I start accepting that Bitcoin? Or, if this infected machine is trying to check in to me, if I did write or install that command and control server, which I wouldn't do. It was just really interesting to see machines sending that sort of information to my IP address. Some other typical ones, I end up seeing all sorts of these micro-tick alerts. Micro-tick makes these little routers. And here you can see this is someone just trying to hack into and infect a micro-tick router. With Suricata, a lot of these rules too, that are created from emerging threats, they will have external resources as well. So you could do a little more information. Some of them have really great links to blog posts. So you can kind of get some information on what's being sent there. Again, just looking at the statistics is interesting. Here you can see, the severities. These Suricata alerts are all broken down into categories. So information leaks, generic, attempted administrator privilege gain, someone trying to hack into the machine. You can look at all the individual signatures. What I found is it's nearly all of it is remote desktop. That's the majority of what I've found. So, see, behavioral. So this is unusually fast terminal server traffic. So it looks like this one machine is just trying to hammer the honeypot over and over again. It's probably try to break in to a remote desktop server, which luckily I'm not running. Again, you can see SSH scans. Another interesting one, again, to always look at, I think, is just the world map. So we can see where these alerts are coming in from. Again, since I'm in the US, that's always going to be the first one. But in this PCAP, it looks like the majority of alerts were from the Netherlands. Looking at that information, so it looks like there was a lot there. So this might take a little while to load. And then again, another interesting tool is always Zeek. So this is kind of the newer one for me, but it's been a lot of fun to play with and just see what kind of information gets spit out here. So I'll open this all up. So again, you're kind of just given these log files with all this information, all these rows. There's so much really interesting information. Again, I've got the community ID there, but using tools such as cut and awk, you can actually, here we can filter down and just look at a few of these columns from the connection log. So we can see the originator's IP address. Using cut and unique, you can actually take a look at just the unique values in that log file and how often they occurred. So that's an interesting one. Looking at something like the different user agents. This is an interesting one. I forget what that one was, but I think if we Google that, well, we can Google that on our own time. I think we are coming up to the time here. Actually, this went by really fast. Lots of SIP traffic. Again, RDP, almost always the top protocol there. Things like the methods. It looks like this server might also have been some sort of proxy server. Zeek is really cool at looking at stuff like the requests, and it's just pulling this data very quickly out of a PCAP and presenting it to you. And you're not going to have the full PCAP data behind, or you're not going to have all of the packets in the log files that Zeek spits out. But if you do have that PCAP, that's one of the reasons why I'm very excited for Community ID. But even still, with just the Zeek logs, you've got that ID, the IP address information, the port information. Then you can create a Wireshark display filter just based on that data to go in and really dive in and see more about what's going on in that connection. But Zeek is going to give you that really nice kind of high level overview. Right. So yeah, just quickly go over some of those interesting finds that I found. Way more RDP than I expected. It's a very common way for attackers to scan. I didn't go into it, but there is a lot of SIP traffic out there, a lot of people scanning for SIP servers. And that's the craziest one, is it looks like my machine was some sort of command and control server for a botnet. So we're getting Bitcoins from infected machines. And then it's sending me its password in the clear text. That was the most surprising one. Yeah, just wrap it up. Kind of all these different tools do have different advantages, disadvantages. Always try to use the right tool for the job. Learning that it's, kind of the number of connections in a PCAP that makes Wireshark a little slower rather than file size. Interesting too. Zeek is really fun to use, and there's lots of data out there if you're willing to listen. I've got some resources here up on the screen. So that's my GitHub repository for this. Some more of that technical information about how the firewall is set up, how the packet capturing is done, the commands. That book, Cuckoo's Egg, I would highly recommend to anyone. There is a group out there called HoneyNet and SANS that do a lot of this type of analysis. And yeah, Chris Sanders' new book, I highly recommend that one. Lots of really interesting ways to use honeypots in a production network, which sounds a little scary, but he makes a very strong case for that. And there are just a lot of really interesting techniques in that book that were a lot of fun to read.
Okay, so I think now's your perfect timing to go ahead and show the QR code for the survey. And take some questions.
I don't know if I have the QR code actually.
Oh darn, no worries. That's
sorry.
okay because it's okay because a link pops up when you leave the meeting, and so if we just go ahead and ask everybody to go ahead and click on the link, because everything you tell us just makes us better. So, got to respect that. And we have actually 10 questions for you on in Q&A. So.
Awesome.
Let's go ahead and hear what you got to say.
All right, so let's start with this first one. It's exactly how to pronounce this here. Gregor's Moscow. So he's asking, what do you think about port knocking as good protection against attacks? I've never used that myself. That technique is kind of, if you're going to SSH into a server, you have to first send connections on multiple ports before the server will accept the connection. I have heard it as a good protection. I wouldn't use it as the only protection. You're definitely going to want a strong password, but it can kind of help obscure how to connect to the network endpoint. All right, the next question I've got is from Jeff. Does the Honeypot do IPv6 as well? I think I mentioned really quick, but no, I didn't configure mine to do IPv6. I just didn't set the firewall up to go over that. So I haven't done that. Luke is asking if there were any VoIP attacks. There actually were a lot. I didn't really have too much time to get into all those ones. We want to just pop back to this real quick. I think we can quickly look at threat assessment. I did end up actually seeing a lot of these VoIP attacks as well. So if we look at something, statistics, actually, you know what? This is where Zeek is the right tool for the job here. So Zeek is also configured to output a SIP log from the SIP traffic and the PCAP. And yeah, you can see from this one little slice, quite a few people scanning for see if this is a VoIP server, to see if they can attack it that way. All right. Roger is asking how often Suricata needs signature updating. As often as you possibly can. I know Emerging Threats releases signatures daily. Every day they're out there writing new signatures, looking at new attacks, and writing new signatures for those. So if you do want to be as up to date as possible, I'd update every night. And the framework program that we used in the live demo, that's CloudShark. So if anyone wants some more information about that, they can let me know. But it's just a web-based interface to those tools, Wireshark, Suricata, and Zeek. Those were the ones we used under the hood there. We've got another question from Dave Cullen. Could weird.log be indicating an unknown exploit behavior? Short answer to that I would say is yes. I didn't have a whole luck finding too many interesting things in the weird log. Mostly it was, you know, looked like programs that were not written very correctly. So that example, you know, not sending technically valid HTTP requests. You know, someone's probably just trying to write a quick little bot and not too concerned with making sure everything is correct. So Ron has another question, a couple down below. Are the weird Zeek requests always legit, or can they be false weirdness? And yeah, they can be false weirdness. You know, they're kind of more of just a pointer to something that might be weird. You know, Zeek is outputting all these log files, but really to do full analysis, I've found you do need the PCAP behind it. You know, to filter down and actually analyze the packets themselves. But Zeek will give you that kind of really quick overview into all that traffic in the PCAP. And so to answer Paul Benya's question, Zeek and Suricata are built into CloudShark. We're using those on the back end behind the scenes to generate that data that we looked at. And Chuck C asked a good question. I didn't get to this, but the droplet did have two interfaces. So once the droplet was up and running, I didn't have the diagram and I didn't talk about it. There was another interface on a private network. So that way I could use another droplet connected to that same private network to pull all these PCAPs off. Cause yeah, once I set the main public IP interface up to forward all those ports and everything, there's no way to access it anymore. I may or may not have done that the first time and locked myself out. And Sake's question, missed the beginning about the setup. Yeah, I was just uploading the PCAPs to the CloudShark instance. Doing all that Zeek, Suricata, Wireshark analysis within CloudShark. I had to do a pre-processing or anything like that. That looks like it was the last one, unless anyone has any other questions or anything else for me.
I know, I wish everybody could go ahead and be able to, you know, you'd be able to hear everybody, but for everyone, yay!
Thank you, Betty. This is a lot of fun. This is a lot of fun.
It's cool stuff, man. It's really cool stuff. And I love being able to see the Zeek and the Suricata and the CloudShark all together.
Right.
It's, you know, it's really nice to see.
Yeah, I was really excited this morning to hear that community ID is going to be in all three tools.
I know.
So you just got one way to go through all the data, tie it all together. They all complement each other very nicely.
Exactly. Cool.
Awesome.
Yeah, I like Ron's comment. Some of us may have honeypots in our future. That's pretty cool.
Yeah, it's a quick little droplet. I think it's cost $5 a month. I just got the cheapest one in it.
Wow.
Just neat to play around with. I mean, and again, just good practice for me using these tools.